Have you ever seen a rated wall that connects to a bare steel member and the contractor fire stops the joint? If you think yes, or even maybe, you're going to want to stick around. Whether we're talking about a rated wall coming up under a bare structural member or an elevator shaft wall connecting to the elevator's support steel. If this is happening on your projects, then you should take a moment to listen and grab the article and read it and share it. Now, before we start, I want to give a quick thank you to Underwriters Laboratory for clarifying this for all of us, particularly Mark St. Ange, who is the lead field engineer with UL Solutions, and Swati Tyagi, who is the manager of industry marketing, also with UL Solutions. Now, to be clear, this is not my article. I'm just reading this because some of our Build Better crew listen to our firestop discussions while they're doing other things. If you want to, you can speed this up and read along. They say that it's an amazing way to retain information if you listen and read at the same time. Let's jump into this article titled Fire Resistance Rated Walls Adjoining Unprotected Steel Beams. The purpose of this article is to gain an overview of code compliance issues with fire resistance rated assemblies attaching to unprotected steel members, or rather non-compliant joint systems. The concern. A current trend at construction sites is fire resistance rated assemblies being constructed so that they connect to unprotected steel members, either at the horizontal head of wall or HW joint, or the vertical joint where the wall connects to a column. Fire resistance rated walls that connect to a bottom flange of an unprotected steel member are one common example. In this instance, a concern would be the inability to install a fire resistance rated head of wall joint at the top of the wall assembly. A joint system installed between two assemblies with different fire resistance ratings can only be matched to the lower of the two ratings. If any component, such as a steel member, is left unprotected, its fire resistance rating is effectively 0. As a result, the entire joint system would also be rated for 0 hours, which means this fails to meet model code requirements that mandate fire resistance rating be continuous to the floor or ceiling above. Secondary concerns. Another concern of this type of construction is that the joint systems used are often not compliant with UL 2079, the standard for tests for fire resistance of building joint systems. UL 2079 specifically evaluates joints installed between two fire resistance rated assemblies. It does not address conditions where one of the assemblies, such as this unprotected steel member, lacks a fire resistance rating. A similar scenario is seen when a rated wall terminates at the underside of a non-rated floor or ceiling assembly. In such cases, UL Solutions testing is conducted with a rated floor assembly to isolate the performance of the joint system from the potential failure of the non-rated floor. These test systems are published under a product category XHBO, otherwise called Continuity Head of Wall Joints, in the UL Product IQ database, which is free to use but does require one-time registration. Model codes. NFPA 101 Life Safety Code and NFPA 5000 Building Construction and Code do not allow fire resistance rated joints to be installed between wall assemblies and an unprotected steel beam. These model codes include a reference to NFPA 221, which explicitly prohibits this condition. NFPA 101 should be a common reference in all construction documents, as it is typically enforced at healthcare occupancies regulated by CMS Joint Commission. NFPA 221, Section 7.2.4 states, the fire barrier wall shall be permitted to terminate at an individually protected structural member in the same plane, provided that the structural member has a fire resistance rating of not less than that required for the fire barrier wall. The International Building Code, or IBC, requires continuity of the wall assembly, which extends from the top of the floor ceiling assembly below to the bottom of the floor above. Unprotected steel members do not comply with this requirement because they would allow the temperature on the unexposed side of the assembly to exceed the maximum temperature allowed by UL 2079 or ASTM E 1966. While the importance of protecting structural steel may seem straightforward, confusion often arises due to an expectation in the IBC that allows certain supporting structural members to remain unprotected. This expectation is frequently used as a cost-saving measure, but it can lead to non-compliance and misinterpretation of fire resistance rated assemblies, especially when joint systems are involved. As a result, the lack of protection can compromise the structural integrity of a fire resistance rated assembly and create challenges in meeting the code requirements. Test standards. To illustrate why unprotected steel members would fail the fire test in UL 2079, it's necessary to understand how the fire testing is performed. Fire testing for the joint is conducted in compliance with UL 2079. During the fire testing, thermocouples are placed at specific locations on the non-fire side of the test assembly not directly exposed to fire. One location of thermocouple placement is at the head of wall, and it would be on the back side of the unprotected steel member. The pass-fail criteria for the temperature rise of thermocouples are exceeding 325 degrees Fahrenheit plus the ambient temperature in the room during the test. The temperature is increased via gas-powered furnace in accordance with the standard time temperature curve in UL 2079. In the fire test, the temperature of the unprotected steel will rise on the unexposed side, and the heat at the head of wall location will be significant. 3.1.1 The conduct of fire tests of materials and construction to be controlled by the standard time temperature curve shown in figure 3.1, which you'll see here. The points on the curve that determine the character are basically 1,000 degrees. The points on the curve that determine its character are, as you see here. So at the 5-minute mark, the temperature inside the furnace is 1,000 degrees Fahrenheit, and you can see the temperature rises. Then also you can see the graph that shows this time temperature curve. Current certifications. The UL product category for certified, listed, head-of-wall fire-resistant rated joints is XHBN. These systems are tested with structural steel protected, and the listings typically specify the use of spray-applied fire-resistant materials, SFRM, or intumescent fire-resistant materials, IFRM, to achieve the required fire resistance rating. A critical aspect of compliance is ensuring that the materials used match those specified in the UL listings and the manufacturer's installation instructions. SFRMs can be formulated with various materials in proportions to deliver specific hourly ratings. Therefore, the entire system must be tested as a unit in order to evaluate essential performance criteria such as the sealant bond strength, movement capabilities, and fire containment integrity. Some certifications specify a particular manufacturer's products, while others allow for generic product types such as cementitious fireproofing or spray fiber fireproofing, which permit the use of any product within that category that meets the required ratings. Education and awareness. To ensure proper application and code compliance, it's essential that code authorities, design professionals, and contractors understand these things: the model code requirements for fire-resisted construction, the complexities and limitations of system listings, the importance of following manufacturer's instructions. Ongoing education and training programs are critical to building the competency needed to achieve reliable fire containment and code-compliant construction. Plan review and field inspections. Fire stopping compliance, especially for joint systems, can be challenging during plan review and inspection. Construction documents often include only general references to listed systems without specifying the exact listing required for each application. To help ensure code compliance, code officials should request that design professionals provide specific listed systems as part of the construction documentation. Field inspections should verify that the installed systems match the listed details, including materials, dimensions, and installation methods. Properly constructed, installed, and maintained listed assemblies and systems are the foundations of code-compliant, fire-resistant construction. These principles are further detailed in the UL Solutions Firestop and Joint System Application Guide. For more information, visit the Code Authority or contact UL Solutions at fire.inspections@ul.com. And again, I'm simply reading this article that was written by Mark St. Ange and Swati Tyagi. Thank you to UL for creating more educational content. We really appreciate it.